This is part 1 of our video on Introduction to Vectors. What we're going to be doing in this part is going through a list of vocabulary that you need to be familiar with when you are working with vectors. So our first word on the list is magnitude. So the magnitude is the size of the amount, how big it is. So if I was looking at a velocity and it was 10 meters per second north, the magnitude would be the 10 meters per second, and the north would be the direction. So the magnitude is the numerical part of a vector, and the direction is which way it is headed or pointing. So when I'm dealing with magnitude, let's say I had the vector x. I show that it's a vector by putting a little arrow on the top. You can do a full arrow with a full arrowhead on the top, or I like to just do half of an arrowhead because you can do it in one motion with your hand. To show that it's just the magnitude of the vector we want, we put 2 vertical lines on either side. And that's notation that we've talked about before briefly in advanced functions. That's called absolute value. Absolute value just looks at the positive value of a number, which is really what magnitude is. So we're not worried about direction, we're just worried about the size of it. So an example, like I said, if it was 10 meters per second north, it would be 10 meters per second as the magnitude part, and then the north would end up being the direction. So when we're writing direction, I like to use the square brackets. That's the standard notation for the direction, is to put it in square brackets. It doesn't have a particular letter or symbol that we use. We just tend to include the direction in square brackets. A scalar measurement is a measurement that does not have direction. So that would be things like speed or your age or a temperature. Those things don't have an associated direction, so they would be a scalar quantity. So I'm going to put an example. I would maybe say that x is 5 centimeters. I don't put the little arrow over top because it's not a vector, it's just the variable x. So x is 5 centimeters. And some examples could be a distance, a speed, temperature, your age. All of those things are numbers that do not have an associated direction. If it has an associated direction, it's a vector quantity, which means instead of just writing x equals 5 centimeters, I would put an arrow over the top of the x, and then we would say 5 centimeters, but we would have to attach a direction with it. So it could be 5 centimeters up or 5 centimeters down, east, west, left, right. I think I'm going to go for north. Right? There needs to be a direction associated with it. So instead of distance, the vector quantity is displacement. We've talked about that in our calculus part of the course. Instead of speed, we would use velocity. Right? These are things that have a direction associated with them. A unit vector is a vector that is just 1 unit long. So there's a special notation for that. It's a little weird. So if I had the variable x, and let's say it is 1 centimeter. So it has to be 1 unit. It could be 1 centimeter, 1 inch, 1 meter, 1 kilometer. And it is a vector quantity, so it does need a direction. I'm just going to throw in north. To show that it's a unit vector, we put a little, it looks like a circumflex, or we've talked about it on your calculator. It's a caret. Right? It's just that weird little up arrow on the top, kind of like it has a roof. And then I'm not really going to give an example. It's just something that is 1 unit long. All right, equal or equivalent vectors are vectors that are equal. They're the same, which means they have to have the same magnitude, so they have to be the same size, and they have to have the same direction. So they have both the same size or the magnitude and the same direction. So that would mean that vector x and vector y are equal. That's how we would write that. So if I did a numerical example, maybe vector x is 10
meters east. And then an equal vector to go with that would be, vector y. It would also have to have the same magnitude, so 10 meters. And it would have to have the same direction, so it would also have to be east. So in order for them to be equal vectors or equivalent vectors, they have to have the same magnitude, the same direction. Now, if I was drawing a vector and they were supposed to be equal, they have to point the same direction and they have to have the same magnitude or the same length. So I'm going to draw just a randomly sized vector here. I'm going to have it point straight up because that will fit on my page. And then in order to have a second one that is equal, it has to be the exact same length. Maybe I should have measured them. And they need to be pointing in the same direction. All right, opposite vectors are vectors that have the same magnitude, but they're going in opposite directions instead. I'm going to start with the examples, and then we'll talk about the notation. So let's say I have vector x, and it was 10 meters east. In order to be an opposite vector, vector y would have to have the same magnitude, so it would be 10 meters. But instead of going east, it now has to go the opposite direction, and the opposite of east is west. If I was drawing a vector, I would draw one. This time I'm going to use my ruler, and I'll actually measure it so that I know that they're equal. I would have one vector perhaps that is pointing up, and then the second vector is going to be the same thing but pointing down. So they're the same length or the same magnitude. Oops. But one is going to go up and one is going to go down. They're pointing in opposite directions. So if they have opposite directions, in our calculus part of the course, we learned that the direction comes from whether the number is positive or negative. So if I was doing 10 meters east, that might be positive 10, and then 10 meters west would be negative 10. So if I had vector x and vector y was opposite, it should have the same magnitude but a different direction, so it would be negative y. All right, parallel vectors are vectors that have either the same or the opposite direction. So just like parallel lines, they are two things that are evenly spaced, right? So they could be both pointing in the same direction. They could both be pointing in opposite directions. They could be different lengths, right? All that matters is that they're either the same or opposite directions, which is what would make them evenly spaced. So if I were to draw, is what I think I'm going to do here. Actually, we'll do an example first. So let's say vector x is 10 meters east. A parallel vector to that would be something maybe 5 meters east, or 7 meters east, or 200 meters east. I'm going to write down 5 meters east. Or it could be a different length. Let's say it is 20 meters, but it could also be going the opposite direction. It could be going west. It cannot go north, it cannot go south, but it could be east or west. If I were to draw two parallel vectors, I don't think I need to measure these ones, so I'm going to use this one. I'm going to have one vector that is going up. I could have a second vector that is also going up. It does not have to be the same length. It just has to be the same direction. Or I could have one that is going down. Once again, it does not have to have the same magnitude. It does not need to be the same length. They just have to have either the same or the opposite direction to be parallel. The notation that we use for parallel, I would use x and y, and then I put two vertical lines in between, which is the mathematical notation for parallel. All right, our last vocabulary words is coincident vectors. They are vectors that have the same direction and they're basically just on top of each other. So coincident vectors are vectors that are touching. So it's basically just two vectors that are sitting on top of each other. So I might have one vector here, and then there's going to be another vector that is just sitting on top of that. Now I am going to draw it a little bit lower just so I can see where it is, but they're basically just two vectors that are touching or that are lying on top of each other. All right, so those are all of our new vocabulary words, and we will practice using them in the next video.